So, very good morning, students. So, welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools or the Mastermind Schools. So, once again, I welcome all the class 9 students for today's session. As you can see on the screen, my subject is physics. We are in class 9. Our ongoing chapter, motion in a plane. And today we are entered to the session number 2. So after completing the first chapter, the basic mathematics in physics, we entered the second chapter, motion in a plane, where we discussed little information about a two-dimension motion. So motion in plane explains about the two-dimension motion, whereas in lower classes 6th, 7th and 8th, we learn about the motion in a straight line. That is, so many ways we discussed. But now in a class 9, we are discussing about the motion in a two-dimension motion, that is along x-axis as well as along y-axis. So in that, there are different types of motions you can see, like the majorly projectile motion, when a body is projected with some angle from the ground. So the path followed by the body, we are discussing about that. In that, we covered few types of motions. What is a projectile motion? And so we'll continue there only where we left in the last class. So that is, there are different types of projectile motions are there. Types of projectile motions. One is oblique projectile motion. Second one is horizontal projectile motion. Third one is projectile motion in inclined plane. Inclined. See, oblique means regular. When you are, suppose you are throwing a body from a ball from here on, you are hitting a ball. It will follow a path called parabolic path. So this is called oblique, from ground to ground. Right? This is called as a oblique projectile motion. Whereas from certain height, suppose you are traveling by flight and you have dropped some bomb. So it will follow a path like this and hits a particular car. So this motion is called horizontal projectile motion. And suppose you are projecting a body on inclined plane, which is making some angle with the horizontal. So this is called the inclined motion, inclined plane, projectile motion on an inclined plane. There are three possible types of projectile motion, right? That we introduced in the last class. So there is a little explanation also given for them. You'll see. So what is oblique projection? In oblique projection, there are some conditions are there, some equations are there, some formulas you can get, right? So see, when you see here, oblique projection is the first case, the first one. When a body is projected from the ground, it will follow parabolic path, and path followed by that is called parabola, and the equation is called, the path is called trajectory. The trajectory is nothing but parabola. The trajectory of the project oblique motion is parabola. So when a particle is thrown obliquely near Earth's surface, it moves along a curved path, provided that particles remains close to the surface of Earth. In projectile motion, horizontal component of velocity is u cos theta, as you know, and acceleration is g, and mechanical energy remains constant, while speed, velocity, vertical component of velocity is sin theta, momentum, kinetic energy, potential energy, all changes. So velocity and kinetic energy at project point of projection will be minimum, but not zero at the highest point. So some conditions are given when a body is projected from the ground. When you are throwing a body from a ground, the path followed by a body is called a projectile, the trajectory, and the shape is parabola. A projectile is thrown with a projectile which is throwing above the ground, thrown with a velocity u at an angle of theta with the horizontal. The velocity u can be resolved into two rectangular components, that is u sin theta, u cos theta. Already we have seen resolution of vectors, right? Based on this is the condition for the oblique projectile. So this is the path followed by the projectile, which is called trajectory. The shape is parabola. In these cases, the horizontal component is u cos theta, vertical component u sin theta. By using that, you can find some formulas. Horizontal motion. So, when the body is moving horizontally, acceleration is 0. The horizontal component is u cos theta along the x-axis, and u sin theta is the along y-axis. For horizontal motion, the formula is x is equal to ut. You get now because u is 0. For horizontal motion, initial velocity is 0. So you can get the formula s is equal to velocity is equal to distance is equal to velocity into time. So if you take velocity along x-axis, the distance traveled along x-axis, x is equal to u is nothing but u cos theta into t. So from this, what is time? Time is equal to x by u cos theta. What is x here? Horizontal distance. Horizontal distance is, so when a body is projected from 0, the horizontal distance is on x-axis. So horizontal distance is given by velocity into time formula. Distance is equal to. So what is the velocity? Horizontal component of velocity. That is u cos theta into time is t. From this you can get the formula for the time. Time is equal to x by u cos theta. That is one formula we got. Right? That is for horizontal motion or oblique motion. Oblique projectile. Right? Then when you move to the next vertical motion. Vertical means along the y-axis. Again, same acceleration is 0 and u is equal to u sin theta along the y-axis. For vertical component, you know formula. Vertically moving means u is equal to ut, s is equal to ut plus half at square. Right. So what is s here? Y. Y is along y-axis. U is nothing but u sin theta into t plus 1 by 2. A is nothing but g, vertical component, a gt square. Okay, you get minus here because vertically upward, going against the gravitational force. That you got. So from equation 1 and 2, combining 1 and 2. Right, in place of t, we substituted the x by u cos theta. Wherever t is there, we substitute, because from equation 1, t is equal to x by u cos theta. From 1 or from 2, whatever it may be. In place of t, if you substitute the x by u cos theta, we get x by u cos theta, x by u cos theta whole square. That's x square. So we got the xy is equal to sin theta by cos theta. This is nothing but tan theta. So we got the equation x tan theta minus 1 by 2 g x square u square cos square theta, which is in the form of y is equal to ax minus bx square. The equation, suppose the trajectory of projectile is parabola. Is the formula for the parabola as per your mathematics. Right? So, horizontal component of velocity, vertical component of velocity. Separately we calculate the horizontal distance and the vertical distance. Then both are equated to one another. And we can find that it is in the form of parabola. Equation is the path of trajectory followed by a oblique projectile is parabola. That is proved here. That is very important derivation when you go to the 11th standard. Right? So, this is in the form of y is equal to ax minus bx square. Clear? Now, some parameters we have to calculate. When a body is in motion, there are some values you need to calculate, that is maximum height. So, what is maximum height? Here, a body is projected from 0. After reaching maximum height, it will come down and again touches the ground. So, if you want to calculate the formula for maximum height, so the height at which vertical component of velocity becomes 0 is called maximum height. Here, what happened? V becomes 0, vertical component. U sin theta becomes 0. Maximum height in case of oblique projection. So, by using formula V square minus U square is equal to 2AS, what we are getting? V is 0. V is 0 only. That's right. So, U square is not, U is U sin theta here. Vertical na? Whole square. Right. Minus, because vertically 2GH. So, from that we got H formula. H is equal to U square sin square theta by 2G. The formula for maximum height in case of oblique projection. Generally, in 8th, 9th class, 8th class, 7th class, what we learn is maximum height is U square by 2G. For a body in plane, straight line. But as it is a vertical column, we can write the sine theta also. U square sine square theta by 2g is a formula for maximum height reached by a vertically projected body or oblique projectile. Okay. So maximum height can be also expressed as h is equal to u square by 2g. Okay. Or h max is equal to u square by 2g when sine theta is maximum 90 degrees. When vertically projected, if you see, vertically projected body theta is 90 degrees. Sine 90 is equal to 1. So then you can get the formula u square by 2g only. So different conditions you can define for the maximum height by a oblique projection. Right. Then time of flight. So time of flight is that flight. What is the flight? For example, from here we are throwing, it is coming here. So the total time for which body is in air, that is from here to here and again here to here. The total time is in air only. Suppose you are throwing a pen. So it is coming like this and again coming to second hand. So the total time for which body is in air is called time of flight. That is equal to, learn in lower class, that is equal to time of ascent, time of descent. So the total time taken by the projectile to go maximum height and come down to the same level from which body is projected is called time of flight. Okay. So vertical upward motion, so formula is, V is equal to U minus GT. So vertical upward motion, V is 0, U is U sin theta minus GT, from where you can get the T value. T is equal to U sin theta by G. That is, here the time to reach maximum height is U sin theta by G. And same, coming down also same only. So time of ascent is always equal to time of descent, which is equal to U sin theta by G. But what is time of flight? TA plus TD. Time of ascent and time of descent. That is U sin theta by G plus U sin theta by G. Right. Both we have to add. Then we get the 2U sin theta by G is the time of flight. 2U sin theta by G. Formula for the time of flight, that is the time for which oblique projected body is in air, means from where you are projecting, it reaches the maximum height, again comes back. So reaching the maximum height is time of ascent, again coming back down is time of descent. Time of ascent plus time of descent is equal to time of flight. Flight, flight will go in air. Similarly, this also same. So we discussed the formula for maximum height, 2U sin theta by G, and time of flight, 2U sin theta by G. That is U squared sin square theta by G, that is 2 times theta by G. Now when you move forward, horizontal range, another important third formula. Horizontal range means when you are projecting from one place, how much maximum distance it travel is called horizontal. See, this is. So from here to here. So this is called horizontal distance, horizontal range. Okay. So horizontal range is nothing but distance only. Distance is equal to velocity into time. So distance, suppose it's a range. So what is velocity? Horizontal, you told, no? Horizontal velocity you have to take U cos theta into time is nothing but time of flight. Here we have to take time of flight because the total time in air. So you can write U cos theta into time of flight. Formula you have to write. Time of flight is nothing but 2U sin theta by G. Correct? In place of T, we wrote 2U sin theta by G. Because when you want to find horizontal range, so you have to calculate the total distance, that is the total time of flight. So distance is equal to velocity into time. So horizontal velocity is nothing but U cos theta, and into time is nothing but time of flight. We already derived. So U cos theta into 2U sin theta by G. So for that formula is there. Sin 2 theta. Sin 2 theta, U sin theta cos theta. 2U sin theta cos theta is nothing but, see, 2U sin theta cos theta is nothing but sin 2 theta. So U square sin 2 theta by G. So U into U square, right? 2 sin theta cos theta is nothing but sin 2 theta. The formula. by g. We already seen in the first chapter. So this is given by the range. Maximum range is given by the formula u square sine 2 theta by g. The third formula. Maximum height, time of flight, and horizontal range. And when you are throwing a body with certain velocity and certain angle, how much maximum distance can cover? We got. Right? So clear. So three formulas of the oblique projection. So there are some special cases in that when it is maximum, how to hit the bomb. Suppose you want to throw a bomb into a particular object. With what angle you can throw so that it will exactly hit the or exactly go for the blast. That is, you have to calculate based on the maximum height. Right? So these all do no need to change in velocity, change in momentum, angle. So this is quarterly about the oblique projection, where we discussed about the three important formulas. One is maximum height reached, time of flight, and horizontal range. So before going for the next, just see this.
You and your friend are standing at the edge of a cliff. Your friend drops a stone straight down, and with great speed, you throw a similar stone horizontally. The question is, which stone will land on the water surface last? Does your intuition tell you that since you threw the stone with greater speed, the stone will take more time to land? If so, you are wrong. Both stones will actually land at the same time. Welcome to the interesting world of projectile motion. Let's go over some fundamental concepts. When you throw a ball at an angle, it never goes straight like this. Instead, it will have an elegant curved path, more specifically, a parabolic path. This kind of projectile motion happens due to the effect of gravity. When thrown at an angle, the object has two components of velocity, one horizontal and one vertical. The gravitational force always acts vertically. When a force acts on a moving object vertically, the horizontal component of velocity never changes. Only the vertical component of the object's velocity will change due to the vertical force. Therefore, the initial horizontal component of velocity you have given will also not change throughout the motion of the object. Let's analyze this more closely and see how the variation of the vertical component of velocity affects the shape of the trajectory. The horizontal and vertical distance traveled by the object for a small time interval is shown here. Its complete motion will be as shown. Since the horizontal component of velocity does not change with time, with an equal time interval, the ball will travel the same distance horizontally. However, the vertical component of velocity has been reduced due to the effect of gravity. Thus, the distance traveled vertically in this time interval will be lesser. Just continue this logic for a few more intervals. You can clearly see the object is taking a curved path. As the vertical velocity keeps on decreasing as the ball travels up, the point where the vertical velocity becomes zero will be the maximum height it can achieve. After this point, the vertical velocity will become negative, and the object will start its descent. During the descent, the gravitational force and velocity are in the same direction, so the vertical velocity will keep increasing. This will be the final shape traced by the ball. The shape of this trajectory is known as a parabola. Here's an interesting thought experiment. This cannon is ejecting a ball perfectly vertically. The ball will come back to its initial position or zero movement in the horizontal direction. Now let's reduce the angle and eject it with the same speed. Now the ball can travel horizontally. With a little more angle reduction, the range increases further. When the cannon's angle is down to 45 degrees, the range becomes even higher. However, if you increase the angle after 45 degrees, the outcome is different. The range actually decreases. The maximum range is at an angle of 45 degrees. Before and after that, the range decreases. Can you guess the reason behind this? The range of the ball is multiplication of the initial horizontal velocity you have given multiplied by the time duration it stays in the air. The time the ball spends in the air decreases as you decrease the angle.
So time of flight.
However, the horizontal velocity keeps on increasing as you reduce the angle. Multiplication of two numbers will be maximum when both the factors have a good value. In this case, the time the ball spent in the air and horizontal velocity has a good value at the angle of 45 degrees. This is why you get maximum range when you throw the ball at 45 degrees. With this understanding of projectile motion, it becomes quite easy to solve the question we posed at the beginning of the video. The time it takes for the stone to hit the ground depends only on its vertical velocity. Even if you have given a high horizontal velocity to your stone, its vertical component is 0. This means both the stones have the same vertical component of velocity at the beginning, 0. This velocity will increase over time due to the effect of gravity, but with the same magnitude. This means the vertical component of velocity of both stones is the same throughout their travel. Therefore, both will hit the ground at the same time. Pretty interesting, right? The greater speed you have given to the stone has no effect at all on its travel time because you threw the stone perfectly horizontally. Thank you for watching.
Right.
We hope you enjoyed the video.
So, you have clearly explained about the projectile, vertical projectile and all, and we have seen the horizontal range, which is maximum at 45 degrees. When you are projecting the body 45 degrees, horizontal range is maximum because you can put the value there and you can find understand. Okay, that is the first case we have done, oblique projection. Oblique projection is the first case where we have done about there are three types of projectiles are there. First one is oblique projectile. This is the second one. From certain height when you drop the body, just like the example shown now, from big hill they are throwing. In such case, again we get the same conditions, equation for the path, that is trajectory, and many, you can get the maximum height, what is the horizontal range, what is the vertical direction. All these things will be the second case also. Right? Case 2, this is. First case we have done, that is oblique projection. We are projecting the body from the ground. It follows the path of parabola, path called trajectory. The trajectory is called parabola. Then we'll discuss about the second and third cases in the next class. Okay. So we are clear about what exactly we discussed. In lower class, when you go to the 8th class, what we learn is when the body is moving in a straight line, you can find what is the maximum height given by the body, maximum reached by the body, and what is the equations of motions under the influence of gravity. Same thing here we are doing when some angle is introduced. As you all know that the vector quantity is resolved into components. So when you are throwing with some velocity, the velocity is resolved into horizontal and vertical component. By considering u cos theta as horizontal component along x-axis, u sin theta is a vertical component along y-axis, we have derived the projectile of oblique motion. Next class we discuss about the horizontal motion of projectile and what are the conditions, same conditions there also. What is maximum height, what is the horizontal range, what is the time of flight. Okay. So we'll discuss in the next class. So that's all for today. Have a wonderful time. Thank you all of you.